Hi. So today I'm going to discuss about cell potential. So basically it's a small topic in electrochemistry. It is used to calculate the potential difference between the two electrodes. Okay, so the electrodes have a potential. So the potential difference between the electrodes and cathode and anode is known as the cell potential. Okay, so we'll see how we calculate on what factors does the cell potential depend. Okay, so calculating cell potential. So you can see in the small inset figure, it's an electrochemical cell and it has two metal strips. They are known as the electrode, and we need to calculate the potential difference between these two electrodes. This is also useful, no? In physics, you calculate you want to know what's the voltage. So this voltage is nothing but cell potential. Okay, it is the EMF for the cell when no current is drawn through the cell. So calculating cell potential, it depends upon which conditions. Okay, there is so all in so in the lab there is some standard condition which is required for calculating the cell potential. Okay, so there is a reference potential. Okay, reference conditions. Okay, so calculating from the reference conditions. So you can see calculating E cell, electrode potential is known as E cell. So E cell, and it is denoted by a knot. A symbol knot is there. Okay. So when standard condition, the symbol knot is there. Okay. So what are the standard condition? The standard condition is that the concentration of the ions and the concentration of the ions in the electrolytes is 1 molar. Okay. And also the temperature is 298 Kelvin and pressure is 1 atmosphere. Okay. So the standard conditions. So if I do this, if I calculate the potential, like cell potential of Daniel cell in the standard condition, okay, it will be same if any of my friend does in another lab in another part of a country or another country. Okay, so cell potential E naught of the cell is denoted by E naught of right minus E naught of left. So this is the N by IUPAC convention. The right In the right part we always use the cathode. In the left part we use the anode. Okay, so this is also called E of cathode minus E of anode. So we'll use this equation to calculate the cell potential of Daniel cell. Okay, so this is a representation of a cell, and since zinc and copper ions are used, so this is a Daniel cell. Okay, so in this the left part is my anode, the right part is my cathode where reduction takes place. So E naught of the cell is E naught of right minus E naught of left, and this is equal to, and we will use the table, we'll use the standard reduction potential table given in the book. Okay, so using the standard reduction potential table, I can get E naught for copper is 0.04 and E naught for zinc is 0.76. So so this gives my E naught of cell is 1.1 volts. Okay, so this was a pretty simple. We can directly use the standard electrode potential table. Okay, so this is the standard reduction potential table. Okay, so here this is basically reduction potential. We measure the reduction potential of the standard electrode potential, and it is at standard condition 298 Kelvin. Okay, and the concentration of the ions are 1 molar. Okay, and pressure is 1 atmosphere. So in this we can get the E naught of all these electrode. For example, copper. In my case, the copper, I can see my copper ions are here. Electrode potential is 0.337. So I've taken it 0.334. And zinc is here. It is minus 0.76. Okay. So I'll go back to my slides. Okay, so I've used this value to calculate the E naught of cell. Okay, so this was standard condition. But what happens in the electrochemical cell? Always the concentrations are not 1 molar. It can change to any value. Okay, so in that case, I cannot use the standard conditions won't be there. Okay, so there will be E cell. So how to calculate E cell? How concentration dependent calculation of E cell. Okay, so there we use the equation called Nernst equation. So this is a basic, is the basic Nernst equation. Okay, so this is my Nernst equation. Okay, where E cell is equal to E naught of cell minus RT NF ln Q. Okay, so Q is my reaction quotient. For example, if this is the reaction, cell reaction, if this is the cell reaction where n moles are exchanged, so reaction quotient is Q is equal to Q is equal to ratio the product concentration to reactant concentration with raised to the bar of their coefficients. Okay, so we'll see how we'll apply this equation, Nernst equation. Okay, so Nernst equation, for example, this is again the cell reaction is written where n is equal to the number of electrons exchanged. For example, oxidation, n electrons are released, reduction, n electrons are gained in a chemical reaction. So E cell is E naught of cell minus RT NF ln Q. Okay, and this ln is natural logarithm. To make it to common logarithm, we multiply by a factor 2.303. So this is my final Nernst equation. Okay, and also the value of constants. R is my gas constant whose value is 8.3. Okay, 8.314, and F is my Faraday's law where F is 9647887 coulomb per mole. Okay, so this RT by F is a constant. Okay, and generally in questions the temperature given is 298 Kelvin. So putting temperature 298 Kelvin, RT by NF into 2.03, I can use to make things life easy. I can use a value 0.059. Okay, so finally my equation becomes E cell is equal to E naught of cell minus 0.059 n log Q. Okay, so finally this becomes a simplified equation for Nernst using Nernst equation when the temperature is 298 Kelvin. Okay, so we'll use this equation to calculate the E cell for Daniell cell. Okay, so for Daniell cell, this is my equation, right? So this is my equation of Daniell cell, but then you can see concentration. Okay, concentrations are different. It is not 1 molar, it is zero point 0.1 molar, zero point 0.2 molar. Okay, now how to calculate it? Okay, so we will follow stepwise. Okay, so I will come on the board to tell you how to do this reaction. Okay, so this is my Daniell cell where concentrations are different. Concentrations are not the standard conditions. So concentrations are zero point 0.1 and zero point 0.2 molar. Okay, so now how to use this? How to calculate the cell potential? In this case, I told you my final Nernst equation. So at temperature T is equal to 298 Kelvin. Okay, so what formula you'll use? E of the cell is equal to E naught of the cell minus 0.059 by n log Q. Okay, so what things you need to find out? Okay, you need to find out what is my n, what is my Q, okay, what is my E cell. Okay, so I will go stepwise. Okay, first I will find out my n. Okay, then I will find out my Q, and then I will find out my E cell. Okay, so three steps. Okay, so first step to find n. So for this I need to write the cell reaction. Okay, so you all know the cell reaction for Daniell cell is simple. So step 1 is cell reaction. Okay, so cell reaction is what? Zn solid. Okay, Zn solid plus Zn 2 plus aqueous changing to Cu, sorry, Zn 2 plus Cu2 plus changing to Cu solid and Zn 2 plus aqueous and Cu solid. Okay, so in this n, n is how much number of electrons exchanged is 2. Okay, why? 2 moles. 2 moles are being exchanged, 2 electrons are being lost. Okay, so n is 2. Q. Q is what? Concentration of products. Okay, Zn square. Okay, raised to the power coefficient. Coefficient is 1 here. So 1. So we can omit it. Coefficient of copper. Okay, by Zn solid. Okay, and then copper 2 plus ions. Okay, so now here the thing is what, for solids it will be 1, the concentration will be 1. Okay, we don't take the concentration of solids, it comes in constant. Okay, so the variable part is only the aqueous part, or and only the aqueous part is the variable part, or the pressure part. Okay, since there is no gas, so no pressure here, just we will take the aqueous part. So Zn concentration is how much? 0.01, and copper concentration is 0.02. 002. So Q is my, okay, so Q is 10, so it becomes 5. So my Q is 5. Okay, so here I got N, I got Q. So now the next step is to calculate E cell. Okay, now I will show you how to calculate E cell. Okay, E cell we will calculate. Earlier also I showed you how to calculate E cell. Okay, so to calculate E naught cell, we have to minus the electrode potential of the right hand side, which is my copper, minus electrode potential of left hand side, which is my zinc. So from the table which I showed you just earlier, the standard electrode potential, this is 0.34 volts. This is minus of 0.76 volts. Okay, so total E of cell becomes 1.1 volt. Okay, so now I will substitute these values E naught cell and NQ, and I will get E cell. Okay, so I will take a pause to erase this. Okay, okay. So E cell is 1.1 volts minus 0.059 by 2 log 5. Okay, so log 5 value. So now log 5 value I have put in here, and this is simple mathematics to calculate, and from this I get the E cell 1.07 volt. Okay, so this was pretty easy because we already know the Daniel cell, we know the cell reaction. Okay, so basically the main thing is we have to know how to write the cell reaction, how to find n number of electrons exchanged. Okay, so we'll do another problem based on that. Okay. So here I have come up with another problem to calculate the E cell. Okay, so this is tin and this is silver. Okay, where concentrations are different. Now my first step will be to write the cell reaction. Okay, cell reaction. Okay, so now how to write the cell reaction, this is also very important. Okay, so you need to write the individual half reactions, and you need to balance the number of electrons exchanged, so that the, for example, Sn, okay, Sn solid is changing to Sn2 plus, okay, and losing 2 electrons, and these 2 electrons has to be accepted by silver, but silver can accept only 1 electron. Okay, so you need to balance this silver half reaction by a stoichiometry of 2. Okay, this is very important in balancing of cell reaction. Okay, so then only the number of electrons exchanged, number of electrons lost in oxidation half reaction is 2. Then only if we multiply, take 2 of silver, then only the number of electrons accepted becomes equal to number of electron lost by in 1, reaction. Okay, so when I add it, I get Sn solid plus 2Ag aqueous giving Sn2 plus aqueous, okay, plus 2Ag solid. Okay, so this is my reaction. Okay, here N is how much? 2. Okay, this is my the first variable I got. The second variable, the reaction quotient Q. Q is equal to products. Okay, so product means Sn2 plus, okay, concentration, and then Ag solid concentration. Okay, so solid I've told you in last problem also, we won't take solid concentration divided by reactant. Reactant solid Sn we won't take Ag. Yeah, Ag concentration we will take since it is aqueous, and Ag is to the power square. Okay, so this is very important in how to write the reaction quotient. So Sn concentration is 0.02. Okay, Ag is 0.001. Okay, so here this is square. Okay, so it becomes Q is 200. Got it? So we got two variables N and Q. Now we need to calculate the E naught of this reaction. Once we get the E naught of this reaction, we'll put all these three values in the Nernst equation to get E cell. Okay, so now I will take a pause to rub this board, and so this is 0.08 minus of 0.136. Okay, so overall it becomes 0.936 volts. Okay, so I have this. Now I will use this. Okay. So this is my Nernst equation. I have written the Nernst equation, and where E cell is E naught of the cell, where this is my N, this is Q. I have put in the value of N2, Q 200, and E cell 0.936. Okay, so this is now simple calculation is there, and I will get my final answer as 0.868 volts. Okay, so I hope with this you you feel you got a feel how to calculate the cell potential of any electrochemical cell. Okay, where the concentrations are not the standard concentrations. Okay,